Welcome to INSITECT. Today we are talking about alarm systems, your first line of defense against intruders.
You know, it's funny, when most people hear alarm system, they still picture a box on the wall and a siren. And it's so outdated.
It is completely. Our mission today is really to get past that noisemaker and focus on what these systems actually are now. We're talking about sophisticated, layered platforms.
Right. Intrusion detection, automated response, and critical continuous monitoring.
Exactly. So this deep dive is all about understanding how they use advanced sensors, complex communication, basically how they spot an intruder before they can do any real damage.
And what's really critical here is that this isn't just about noise anymore. It's about reliability. It's about designing systems with high availability networks, strategic sensor placement, and making sure everything meets tough standards like UL 681 or the European EN 50131.
If you're not meeting those standards, you haven't really built a security system.
You built a suggestion box.
Right. So let's unpack that. Let's start with the foundational why. Beyond the siren, what are the core jobs of a modern system?
It really boils down to three things. Detect, process, and respond. Detection is the sense or door opening, movement, something physical.
Okay.
Processing, that's the control panel.
Yeah.
It's the brain that evaluates that signal. And then response, that's the siren, sure, but more importantly, it's the notification to the monitoring center.
That notification part seems to be the real fork in the road. You see a lot of unmonitored systems out there, a loud noise and maybe a push alert to your phone. But all the research, all the professionals, they point to monitored systems. Why is that divide so stark?
It's the human element. It's the workflow. A monitored system connects to a 247 central station with a trained operator.
Someone who's always awake.
Always. An alert on your phone is great if you're not in a meeting or on a plane. A monitored system means a professional is verifying the alert and dispatching help. You're not the one responsible for making that critical call in the middle of a crisis.
And when that signal does hit the monitoring center, it's not just a blind call to 911 anymore, is it? We have things like enhanced call verification, ECV.
Oh, ECV is a complete game changer. It tackles the single biggest historical problem with alarms: false alarms.
A boy who cried wolf problem.
Exactly. With ECV, operators have to try the premises first and then at least one other contact number before they dispatch police.
So they're confirming it's not just someone who forgot their code.
Right. And what's really interesting is that many cities and towns now require ECV compliance just to get an alarm permit. It's not a luxury feature anymore. It's becoming a regulatory necessity.
Which makes sense. Police are going to treat a verified alarm with much higher priority. So moving to the physical side, how do we structure the defense? It's not just one motion sensor in the main hall, I assume.
No, you think in layers.
Yeah.
Or rings of defense. You always start with the perimeter doors, windows, skylights. That's your first chance to detect an intrusion, right at the boundary.
And if they get past that?
That's where your second ring, the interior detection, comes in. Motion sensors, things like that. They're the backup. There to catch anyone who managed to bypass the perimeter.
Okay, that sounds systematic. But here's the skepticism I always hear. If this is my main defense, how tough is it really? What happens when a smart attacker tries to jam it or cut the wires or just smash the panel?
That is the absolute core challenge, because the quickest way to beat any security system is to cut off its ability to communicate. If the signal doesn't get out, the system is useless.
So it all comes down to the connection.
It does, which is why redundancy is now mandatory for any serious application.
Let's talk about the connections themselves.
Yeah.
Wired versus wireless.
Sure. So wired systems are the gold standard for reliability, especially in new construction. Physical cables are immune to RF jamming.
But they're a pain to install in an existing building.
A huge pain, which is why wireless is so popular for retrofits. But any good wireless system must have jamming detection built in. If an attacker tries to block the RF signal, the panel has to know and report that failure immediately.
But even then, you're still relying on one path out, whether it's your internet or a cellular signal. That's a single point of failure.
And that brings us to the real professional solution: dual path signaling.
This is what separates the consumer-grade stuff from the commercial systems.
Absolutely. Dual path is mandatory for high security sites. You use your internet connection, your IP network, as the primary path, but you have a completely separate cellular or GSM path as a backup.
So if the intruder cuts the cable line outside,
The system doesn't even blink. It just auto-switches to the cellular path and sends the signal. It defeats the most common tactic used by organized burglars.
okay, so you have two paths. How do you know they're both actually working? You can't just hope the backup is ready when you need it.
You can't. And that's where communication supervision comes in. It's mandatory testing. UL 681, for example, requires the system to check its communication paths at least once every 24 hours.
Just a little digital heartbeat to the central station.
Exactly. And for really sensitive sites, that check-in might happen every few minutes. It ensures the line hasn't been quietly cut.
Let's move inside then. The intruder gets past the perimeter, they're inside, and they find the control panel. What stops them from just ripping it off the wall?
Well, two things: physical and logical hardening. Physically, every professional panel has a tamper switch. The second you try to open the enclosure, an alarm is triggered.
Before they can even get to the circuit board.
Right. And logically, all the communication on the internal wiring between the sensors and the panel, it's encrypted. You can't just tap into the wire and spoof a signal. And of course, you have big backup batteries for power cuts.
This is where it gets really smart for me, though. The system isn't just reacting, it's analyzing patterns.
It is. Modern panels use intrusion pattern recognition. They learn the environment. They can filter out things like the HVAC system kicking on or sunlight moving across a room, which used to cause tons of false alarms.
And the most impressive part of that logic is what they call sequential activation analysis. It sounds complex, but it's really just applying common sense, right?
It's exactly that. Think about a real break-in. An intruder has to open a window before they can walk past a motion detector inside.
So the window sensor has to trigger first.
It has to. If the interior motion sensor triggers, but none of the perimeter sensors have, the sequence is illogical. The panel might flag that as a malfunction, or maybe a pet, but not as a forced entry.
That's brilliant. It's using logic to weed out the noise. And to take that even further, we have specific verification logic, like cross-zone verification.
Yeah, cross-zone is another great tool for reducing false alarms. It basically requires two different sensors to trip within a short period of time before it sends a full-blown alarm.
So motion in the hallway plus a door contact on an office.
For instance, yes. It confirms the movement is not isolated. Many modern panels compliant with SIA CP01 have this built right in. It saves businesses a fortune in municipal fines.
And then there's the highest standard of all, the one that gets the fastest police response, video verification.
This is the gold standard. When a sensor trips, the system grabs a short video clip from a nearby camera and sends it straight to the monitoring operator.
So a human being is laying eyes on the event in real time.
In seconds. They can see if it's a person with a crowbar or a raccoon that got in through the ceiling. There's no ambiguity. And police know when they're responding to a video-verified alarm, they're rolling up on a crime in progress.
That is a huge leap from just a blaring siren. Okay, let's simplify for a moment. Let's get down to the actual hardware. What are the key sensor technologies doing all this work?
Well, the workhorse is the motion sensor. The most common type is passive infrared, or PIR. It's just looking for changes in heat energy, basically body heat moving across its field of view.
But PIRs can be finicky. A draft, sunlight, an intruder wearing heavily insulated clothes.
They can be. And that's why the industry really moved to dual technology sensors.
So it's like giving the system a second opinion.
That's a perfect way to put it. A dual tech requires two different technologies to agree. It has the PIR for heat, but it also has a microwave detector that uses the Doppler effect to see actual movement.
Both have to trip at the same time.
Both. The odds of an environmental factor, like a gust of wind, fooling both a heat sensor and a motion sensor simultaneously are incredibly low. It just kills false alarms.
Okay, what about the perimeter? We've got the classic magnetic contacts on doors.
Simple, but effective. But the professional versions have a key feature.
Yeah.
They are supervised contacts.
Meaning
Meaning the system isn't just watching if the door is open or closed, it's watching the wire itself. If an intruder tries to cut the cable to bypass the sensor, that act alone triggers an alarm.
Ah, clever. And for windows, we've got glass break sensors.
Right, and there are two main types: acoustic, which are tuned to the specific sound frequency of shattering glass, and shock sensors, which detect the physical vibration of an impact. Often they'll use a combination of both for full coverage.
And the brain of the system, the control panel, the architecture there matters a lot, doesn't it? Especially for bigger buildings.
It matters immensely. You have your basic zone-based systems where you group sensors together. It's cheaper up front. Zone 4 might be all the windows on the first floor.
But if an alarm goes off, you don't know which window it was.
Exactly. Which is why for any large commercial or industrial job, you specify an addressable system.
Where every single sensor has its own unique digital address.
Every single one. So the panel doesn't just say fault in zone 4. It says fault at door contact 12B west loading dock. It speeds up response and it makes maintenance 1,000 times easier and cheaper.
Okay, one last piece of tech before we move on. The difference between a panic alert and a duress code. People sometimes mix these up.
They do. A panic button is straightforward. It's a button you press in an emergency for a silent alarm. A duress code is much more subtle. It's a special code you enter at the keypad when you're being forced to disarm the system by an attacker.
So it looks like you're turning the alarm off.
It looks completely normal, the siren goes off, but silently, it sends an intrusion alert to the monitoring center, letting them know you are there, under duress, and need immediate silent dispatch.
That kind of situational awareness is exactly what modern security is all about, which I think is a great transition to our takeaway: integration and maintenance. The alarm system isn't an island anymore.
Not at all. It's becoming the central hub. The most powerful integration we see is with access control.
So when I swipe my card to get in a door,
That card swipe can automatically disarm that area of the building.
yeah.
But the real win is on the back end. When an employee leaves the company, you disable their access card and their alarm code in one single action. It closes a massive security gap.
And obviously, integration with CCTV is a must. We talked about video verification, but it goes beyond that.
For sure, an intrusion event can automatically point cameras to the right location, start recording in high quality, and tag that footage. It's all about preserving evidence.
With all this complexity, maintenance can't be an afterthought. You can't just set it and forget it.
Absolutely not. You need regular testing. Annual system tests are often required for insurance or compliance, but we also push for monthly user tests to catch things like dying batteries early.
And we have to talk about the cyber risk here. This is all software.
It is, and manufacturers are constantly pushing out firmware updates to patch bugs and, more importantly, to close security vulnerabilities. If your physical security panel isn't patched, it could be a backdoor for a cyber attack that takes down your whole system.
It's all connected.
It really is. And all this programming and troubleshooting, keeping it compliant with standards like SIA CP01, it also helps you avoid those huge municipal fines for false alarms we talked about.
So let's just pull back for a final thought here. We're integrating everything: access control, motion logs, video clips, user codes. We are collecting a ton of highly sensitive data on where people are and when they move.
We are, and that brings up a massive issue. Data security is now inseparable from physical security. We're using strong encryption, things like AES 256, to protect the data in transit. But here's the provocative thought for you to really think about. What are the long-term compliance implications? With regulations like GDPR or CCPA, how do you handle all this physical access and motion data? It's highly personal, and it's being logged and stored constantly. That's a huge regulatory challenge on the horizon.
That is definitely the next frontier where security and policy collide. So today we've covered the evolution of alarm systems from simple noisemakers to these integrated intelligent platforms. The takeaways for me are the absolute necessity of dual path signaling, the incredible reliability of video verification, and the fact that you have to adhere to standards like UL 681 to be taken seriously.
I think that's right. Organizations have to realize that true intrusion protection requires investing in professionally monitored, dual-path integrated systems. Anything less is just leaving the door open, not just to physical threats, but to major data compliance risks as well.
Thanks for listening. We will continue to talk about security and technology. See you in the next episode.